finally made it, the last lesson of the lockdown, hopefully. Hopefully we'll be back in September and there'll be no more lockdowns. So we are now at the end of this wired and wireless network protocols and layers. And today I'm going to look at layers and probably just finish off a little bit with protocols. As I said in the previous lessons, that we'll deal with network security when we come back in September. So what we are doing in this lesson is looking at the concept of layers, and that is really important. I don't really want you to have a depth of understanding of how layers work. I just need you to understand how they are used in a general sense. So to begin with, I'm going to go back to the last lesson with a couple of things. First of all, we dealt with sort of sending information on the internet, and I kind of mentioned that it might go via several routes. It doesn't go from one computer directly to another computer. That's the packets. And so I'm going to show you a couple of things. I'm going to show you about ping and something called traceroute, and I'm also going to talk a little bit about packet sniffing, which really comes into security, but I thought it might be nice if we just discussed it now. So let's start with ping, and I've got sort of Windows 7 Windows 7 here, and if we go to the command line, if you've got Windows, if you can get to the command line, these things should be available to you. So this is the command line, and if I type ping, P-I-N-G, and then either an IP address or a domain name, knowing that we're going to be using a domain server which will find the IP address, we should be able to see information about how the data is being sent across the network. So I'm going to look at Google, which is www.google.com, and you probably saw it in the browser beneath. There we go. I've got google.com. So when I press enter, it's going to send in some packets of data to Google, and Google's address seems to be 172.217.169.36. That would be quite nice if we could sort of type that in. Let's see if I can type that IP address into, it's already got Google up, but let's type in the IP address 172.217.169.36, and hopefully that should be the address of Google, and there it is. So this sent some packets of information. It sent 4 packets to Google. It received 4 packets back. It didn't lose any. Now, it's one good way of testing whether your network is working or not. Sometimes you will lose 25%, which means that you don't have a very good network connection. And it took around about 22 milliseconds to actually do that round trip to Google. Another thing that I can do is find out where it went. Now, this is the TTL is time to live, and we have a certain amount of hops that's going from one computer or one router to another router is called a hop, and generally we have about 30 hops before the packet is deemed lost in the network, and we've also got a time to live being 127 milliseconds. So if it takes too long, then if it takes 127 milliseconds, it dies, and then it's asked again, or the sending computer is asked again for that data. So there's 2 pieces of sort of checking on how long it's got to live and how many hops it does. So this one is going to tell me how many hops or what it or where it's going to get to Google, and it's not straight to Google. At least I hope it's not. So if I type in that address again, google.com, the DNS name, and there it goes. So notice that I've got a different address for Google this time, an IP address. Starts with 216.58.212. But this time it's told me everywhere it's going to go. So it started at 10.0.2.2. I have no idea where that is. And then it's hit my Sky router, 192.168.0.1. That's my Sky hub. And then it goes to skybroadband.com at this address. So I could type that in and get to Sky Broadband. Then it's hopped to another one. Hobart isp.sky, so it's still at Sky, but we've got a different IP address there, so it's hopped next one over to still in Sky at a different address altogether. So it's passing this information from one router to another, and then it seems to go on the internet. I don't know where that is, but we could probably try typing it in and finding out. And this seems to be on the same network, so maybe this is the DNS servers. And finally, it goes to this site, which is this address, and that's the trace complete. And it's got a maximum of 30 hops, 30 different places it can go. Each one of these is a hop. And this is how long it's taking to do the hops. So it took a millisecond, and 2 milliseconds, 9 milliseconds, 16 milliseconds. It's going around the world in milliseconds. Now let's just do one more thing. I've got my own website hosted on my computer just upstairs, and I've got a DNS name called learn.homedns.org. So if I go there, I get my website up. But that's gone outside of the house looking for my website, hopefully. So if I sort of do a trace route for learn.homedns.org, straight away I can see it's given me my home, my public IP address of my router, and it's just got 2 hops. If I do it internally, now I know the address that my let's go on to this one. The address of my computer upstairs on my network is 192.168.0.18. I press that, I get the same page, but I could also trace that route. See where that goes. 192.168.0.18, and we'll see the difference in the route. And that was pretty quick starting off, but it's now gone a little bit slower. And actually it's a lot slower than going out to the DNS server and coming back into my computer than it is with a direct contact inside the house. So that's quite interesting. We could also ping those two. So ping learn.homedns.org and see how fast that goes. So it's getting a reply from the public server, and it took 7 milliseconds on average to send the data from this computer back to my own computer. And if I did the same, if I pinged it with the internal, so I'm not going outside of the house, and we can see the difference in the time. Average 14 milliseconds. So it's actually slower on my home network going inside my house from downstairs to upstairs than it is to go outside, find the DNS server, find my address and come back and pull that site. So that's quite interesting. So that's ping and trace route. So I've shown you that just to put you into mind that when you send a packet of data, it can go to all sorts of computers. It's not a straight connection. It can go anywhere around the world. The other one is packet sniffing. Now, if you're on a laptop and you are using a Wi-Fi network, maybe you're in a cafe or a pub or something like that, or outside somebody's house even, you can sort of sniff the packets, that's what they term it, and you can read that data. Now, on a Windows computer, you probably either have to write the software or download it. On the Mac computer, all I need to do is open my wireless diagnostics, ignore this, go to File, Window, sorry, and I've got my sniffer. So that is asking me what channel. Remember, we dealt with channels before on the network. This is a 2.4 gig network, so I will have 14 channels, each taking up 20 megahertz. I can change how wide I look across that band, or I can actually change the channel, or I can even go into 5 gig channels and have a look. Notice that on 5 gig the separation is rather larger. But that, if I clicked on start, would then look at all my network traffic and it would sniff the packet, so I could pick up the data that was being sent. That can happen anywhere. As long as I take my laptop, if I bring it into school, I can sniff the school network. If I take it to a pub, I can sniff that network. So if somebody's making a lot of transactions through eBay and sending their credit card details, then I can pick that up. So that's one good reason to use a VPN, so that it, or even HTTPS, a secure protocol, so that the data is encrypted and I just can't read it. I could just sit there and do that all day long. Right, on to today's lesson then. The concept of layers. So really what we're talking about is a protocol is a set of rules for communicating on a network. And it uses something called layers to do this. Now imagine that I'm going to buy an apple pie and some custard from the canteen at school. I just want my apple pie and custard. I'm really not bothered in the process of how it got there. I just want to eat it. But the process starts off at an orchard with people growing apples on trees. Now, they're not interested in whether I want an apple pie or custard. They're not interested in whether I want just plain apples from Tesco's or whether I want to buy cider made from apples. They just grow them. And that's their job, that's their process. So that is one layer, the orchard just growing apples. But to get the pie, we need a baker because the pie needs to be baked. Now the baker is really only interested in asking the orchard to supply apples and maybe a few other suppliers such as flour, etc. to make the pie and maybe milk to make the custard. But it's another layer in my process. So the baker just bakes the apple pie, really not interested in who eats the apple pie, where it goes, just bakes apple pies. That's all it does. So it's not bothered what's in the apple grower level layer or in the next layer, which is how to get the apple pie to the school. So we've got a transport layer here, which maybe puts the apple pies on a lorry or a van, may deliver them to Tesco's, may deliver them to the school. Hopefully they'll deliver them to the school. But the transport layer is really not interested in the process that the bakers do. And it certainly cannot get to the orchard with the apple growers. That's out of reach. But it certainly needs these processes to be able to get an apple pie. So finally it delivers it to the school, and then we've got the school layer, and the canteen just heats up the pre-made apple pie, pours the custard on it, or might even make the custard themselves, and then sells it to you. Now, all of these processes here are separate. They're all jobs, they're all processes that happen separately. They're in independent layers, but all together they are what is needed for you to be able to have an apple pie and custard from the canteen. So that is the concept of buying an apple pie and custard from the canteen. And we're going to look at the concept of transmitting data around a network. We've got a 4-layer model, and I say a 4-layer model. There are many different kinds of models that we can do, and this is just one protocol. This is for the TCP IP protocol. So it's got 4 layers, which I'll explain a bit later. It's got an application layer, and then it's got a transport layer, then it's got an internet layer, and finally it's got a network access layer. 4 different processes. They just do their job. They're not really interested in what's going on. The application layer does its job, then passes it on to the transport layer. The transport layer does its job, passes it on to the internet layer, and so on. Now these arrows are sort of backwards and forwards. So the application layer can send its information to the transport layer, and the transport layer can ask the application layer for its information. But these later layers can't see it. They've got to go through the earlier layers. So this is a kind of what we call a hierarchy. You have to go through each and every single one. You can't jump from the network access layer to the application layer. It has to go through all of these individual layers. When they're arranged like this, the layers, they're called a stack, and the data must pass through all the layers of the stack. So we've got incoming data and we've got outgoing data. So if you've got outgoing data, what do I mean by that? Maybe you're writing an email. You'd start off at the application layer in an app, writing the email, and then it would go through all of these layers to the network and be sent across the network. The computer at the other end would receive your email, and it would take it back through all of these levels back to the application level layer, and then you'd be able to read your email. So the data has to go through all of these layers. Now, protocols are normally separated into different layers, and they're kind of responsible for doing different jobs, rather like the apple orchard, where we got the grower, and then we got a baker, then we got somebody who drove the van, then we got somebody who sold the apple pie to you. We've got a very similar situation here, and we've got a couple of different models. The one on the left here, the 3-layer model, is the basic model for most protocols. It has to have an application, such as an email client or a web browser. It has to have a network which it passes it on to. And by network, I'm talking the router and how the packets are built before it goes on to what we call a physical layer, which is probably the wires or the radio frequency. But in the exam, they're really considering this model, the 4-layer model, which is the TCP/IP protocol. So you will need to be aware of exactly these 4 levels: application layer, transport layer, the internet layer, and the network access layer. And I've got up here another website. This is basic networking. The biggest one is the 7-layer OSI model, and if I take a look at this picture, we've got application layer, which moves it onto the presentation layer, moves it onto the session layer, transport, network, data link, and finally the physical layer, and then back up to your application. So 7 layers is sort of the maximum. We have a basic 3-layer model to sort of model transmission of data over a network, but the one that we're really interested in is the 4-layer model. I'm saying this because if you search up for revision network layers and models, then I'm afraid you're going to be met with some really, really complex information, very difficult to understand. That's why this is just a concept. It's going to be a simple overview, even though it might be a little hard to understand. So let's go through the layers. The application layer, that's really bothered with collecting and distributing the data. So when you type an email or you do some file transfer from, or you save a file from Word, that's the layer that you are in. It's only bothered with the data that you've actually typed. So it needs to know what needs to be communicated either to a server. So maybe you're asking for a web page, or you're typing in an address. You type it in the application layer. It wants to know what needs to be communicated. Maybe you're saving a Word file. It needs to know what that data is it needs to save. Or maybe you're writing an email. It needs to know what that data is you want to send. It doesn't really care who you're sending it to, how you're sending it to at all. It's only concerned with what the actual data is, because it's going to break that down into the packets. It's going to make the payload for the packets. So it provides services to applications such as web browsers and email clients, and that's where requests are made to web servers. So that's the application layer, and the protocols involved in this will be the file transfer protocol, hypertext transfer protocol, the secure version, simple mail transfer protocol, POP transfer protocol, and IMAP. All of these different protocols would be along with the application layer. So once you've written your email, it needs to go onto the transport layer. And what this is building those packets. So it's kind of making up how many packets, what is the error correction, how are we going to do it. And so it's really just making up the header and the trailer of the packet. The application layer was making up the payload. So this is bothered with the header and the trailer, but not all of the header. Okay, that comes in the next layer. So this is really bothered with packet number, size of packet, and what checksums you are using. And it uses some protocols. Mainly it uses the transmission control protocol, TCP, or it can use something called a user datagram protocol, UDP, which we don't deal with. It's just another protocol. So it divides the data into different packets, and its responsibility is to check that it's been sent and received. So the computers will talk to this transport layer to say whether it's received the message or whether it hasn't. That's part of the trailer in the checksum. Now let me just nip on over to my router. I want to show you one of or some more protocols in here. Whoops. It'd be a lot better if I actually typed in a password. So if I go over to Advanced and Firewall, the demilitarized zone, I've got here the protocols from addresses. So I can check how data is being sent and deal with it in my firewall depending on the protocol it receives. And if I click on this one, I can see that I've got the UDP protocol here. At the moment, it's set up just for the transmission, the 4-layer protocol. But there's a UDP, the datagram protocol there, and there's another one there, ICMP. So these are all different protocols that my firewall can look to see if the messages have been sent on those rules and dismiss or accept the messages on that. So let's go back to our transport layer. So that was part of the transport layer, TCP or UDP. Next layer along is the internet layer. So this actually is where the routers start becoming involved externally on the internet. So it allows exchange of data between lots of networks. And really this is dealing with the header of your packet. What it's doing is pulling up the IP addresses from the sender and the IP address of the receiver, and it's putting that information into your data packet. So it says here the purpose is to add the source and destination IP address of the data. This is your internet protocol. Previous one was your TCP protocol. This one is also sometimes called the network layer, but that can be a bit of a misnomer, badly named, as we will see in the next slide. So this internet layer here is really responsible for putting the addresses on the packets. The next layer, which is called the network access layer, and I've starred it there red, I've seen this one be called the network layer, which is another name for the layer that we just looked at. However, this one isn't really going to be putting the IP addresses in the header. What this is concerned with is making sure that the correct transmission media is used so it can send data over a local network, the LAN. So this is probably MAC addressing, things like that. It ensures that the hardware on the network can be used to transmit the data, and any transmission media can be used. So it can use Ethernet cables, or it can use the radio waves for Wi-Fi. So really this is how it moves around your own LAN, your own little network. And sometimes this is also called the data link layer. So the protocols that are involved with this are Ethernet or Wi-Fi protocols, which we won't go into. I'm just going back to the previous one. We had the IP protocol for the internet layer, and I just want to go back to the TCP. So when we're looking at TCP IP, this is what it really means. It needs to go through the transport layer, and then it needs to go through the adding the IPs to the headers layer, and finally it needs to go onto the network access layer so it can send the data around the network. And we saw that roughly when I was looking at pinging and traceroute. So physical layer. Now when I started off, I gave you the three layer model, the basic model. Everything is sort of built on top of this. This isn't an actual model that we use, it's the basis of one. And this really is the way that information is transmitted. It needs to know in the application what is being communicated. So it might be an email, it might be a Word file, and it needs to break that data down to make the payloads. Then the network layer needs to know who the data is being sent to. Now this one would involve both the TCP and the IP layer. So this is what would be responsible for putting the MAC addresses in or the IP addresses in and sending it through the routers. And then finally we've got the physical layer, which is how will it get there? Will it use wires? Will it use radio waves? It really is bothered with the physical aspects, you know, the actual cabling of the network. So that is the basic three-layer model, and we just looked at the TCP IP transmitting data using that protocol. So that's it. Layers is quite difficult to get through. You just need to know the concept, and I think I've outlined the concept there. You can go into it in a little bit more detail, but be careful online because it is really, really complex. And I don't think any of the revision guides actually deal with it in any useful sense. Just know that the application is your program that you're writing, and then you've got your transport layer, your network layer. That's basically all you need to know. So this year, what have we done? We've done the programming project that's completed, raring to go off to the exam board. We've looked at the architecture of PCs and CPUs. We've looked at things such as the hard drives and the different kinds of media that we can use. We started in lockdown looking at data representation. That's quite a big one that you need to get into, so go back over it if you can. Particularly the logic, you need to be up to speed on logic gates. They're quite a big thing in computing. And we've just taken a look at wired and wireless networks. Obviously, we've got next year the network security to start with in September, and then any legislation. So we're going to look at the laws govern it, such as the Creative Commons licenses, the Data Protection Act, Computer Misuse Act. But one of the biggest parts that we've got to do, and when I'm talking about next year, I'm thinking between September and Christmas when you're going to sit your mocks. Although there might be some changes introduced because of the lockdown. There's a lot of news items, particularly with exam boards, saying that they need to change the way exams are done next year because we've lost a lot of time. But one of the big parts is algorithms. You need to get back into programming. You need to understand how to program and do it on paper without having a computer available, because the exam will be on paper. So you'll need to be able to read programs and understand what they're on about. You'll need to be able to write programs or bits of programs, and you'll need to look at things called algorithms. That's like searching and sorting through data. So I need you to be up to speed on your programming skills. I've done a lot of videos in the past on programming. Have a look. If you can't download Python and have it on your machine, I've given you the address repl.it languages Python 2, so that you can program online with Python. Just don't use your devices. It's very difficult to program with devices really set up to use a computer. Also take a look at different languages. PHP would be a useful language, particularly when we come to using the web and writing web-based programs, talking to databases. So we're going to deal with those next year. So it might be useful to have an idea of what PHP does. Have a play around with it. Look at some videos. Look at my videos. Over the summer, I'll be creating more videos with programming in mind. So that's it. We're finished. One last thing to say. Unfortunately, I am retiring this year. That doesn't mean I won't be around in September. I'm still responsible for the course. I'll still be teaching you the course. I will be in school a few days a week, but I won't be in school all the time. So I'll still be taking all of your revision, still be doing all of your lessons, still be responsible for creating all the work. But it's been fun, and there has to come a time where I need to take a step back and gain myself some time so I can do all of this work. It's been great teaching you. I've had lots of laughs. Hopefully you're going to learn. Hopefully you're going to do well. And I'll be with you next year, but not so much. So that's it. Over to you now. Have a go at the exercises, a few exam questions, and that's it for this year. Please do some work over the summer break. Even if you've got to watch my videos, which I know they're boring, but give it a go. But there's plenty of online videos teaching you how to program in Python and PHP. Please learn the languages. You need to do that. Enjoy your summer break. See you in September.